Hello, welcome to our lessons on polygon properties. We are going to know more about polygons. What are we going to know at the end of this lessons? Let's look at some objectives of this lesson. At the end of the lesson, we'll be able to understand the properties of polygons. We are also going to be able to list the types of polygons based on the number of sides. Yes, we have types of polygons. We are going to know all of that. You're also going to be able to write polygon formulas based on the number of sides, the internal angle, sum of internal angles, and then external angle. We'll also be able to use the formulas to solve problems involving polygons. So we ask ourselves, what is a polygon? Basically, it's a closed plane figure made up of several line segments that are joined together. So a polygon is a plane figure. You know what a plane figure is? Yes, a 2D figure. Yes, a two-dimensional figure is what we are calling a polygon, and it's made up of several line segments that are joined together. So the lines are we'll see examples of other types of polygons, and we'll get this better. It has exactly two sides meet at a vertex. So two line segments meet at a point, which we are calling a vertex. Also, polygons are named according to the number of sides and angles they have. So most familiar polygons we know are triangles, and then rectangles, and then squares. We are saying triangle because a triangle is a three-sided figure. So based on the number of sides, we are naming our polygons. A rectangle, four-sided figure. A square is also a four-sided figure. All of these are polygons. A regular polygon is one that has equal sides. So regular polygon are both equiangular, meaning all the internal angles are the same, and equilateral, meaning it has all sides equal. Examples that we are familiar with are the equilateral triangle, which has all three sides and then all three internal angles equal, and the square also has all four sides equal and then all internal angles the same. So a polygon which has this feature is called, or which have these features, which is equiangular and equilateral, is called a regular polygon. Okay, so let's look at the types of polygons we have based on the number of sides. So we are calling this a triangle. It has three sides. Quadrilateral. It can be any four-sided plane figure, whether a square or a rhombus or a parallelogram or a rectangle, or what you call it, quadrilateral, four-sided, so four sides. We also have a pentagon, five-sided polygon, so it has five sides. A hexagon, six sides. Heptagon, seven sides. It goes on and on. Octagon, nonagon, and so decagon will have 10 sides. Decagon, 10 sides. Yes. Okay, so let's look at the formulas which we can come up involving polygons. Yes. We see this figure here. This is an example of a polygon. So we see this angle here. That's what we are calling the internal angles. So where these two line segments meet, which we are calling a vertex, that angle between those two line segments, so we are calling the internal angle. So this is another internal angle. This is also another internal angle. This is also another internal angle. And this is also another internal angle. So we can see from here that this polygon here is not a regular polygon because the sides are not the same. This side is longer than this side here, and so the angles or the internal angles will also not be the same. So this is what we are calling a side, and then we are seeing a vertex here and then a diagonal. So from this point to this point of the polygon, we can draw a diagonal. So we can draw another diagonal from here to this point. You can call that to a diagonal. And so this is the exterior angle. So angle outside the polygon is what we are calling exterior angle. Yes, so what formulas can we come up with polygons? So we are saying let n be equals the number of sides of the polygon. So the number of sides the polygon has, we are representing it with a variable n. So we generate our first equation. We say the sum of interior angles. So all of these interior angles we are seeing here, we are summing them up, and then that gives us the number of sides minus 2 multiplied by 180. We are going to see where we generated this n minus 2. Look at these two figures. This is a parallelogram or a quadrilateral four-sided polygon. We are drawing a diagonal from A to D. You realize that we have two triangles within this quadrilateral. So two triangles, and we know that for a triangle, sum of interior angles add up to 180 degrees. And this quadrilateral or this polygon has four sides, but two triangles. So the number of sides minus this 2 here gives us the number of triangles within this quadrilateral or this polygon. So the number of triangles is 2. So if we want to know the sum of interior angles, then we multiply the number of triangles we are forming from this polygon by 180. So 2 triangles multiplied by the sum of interior angles of a triangle, which is 180. That gives us the sum of interior angles of the quadrilateral. So 4 minus 2 multiplied by 180, we calculate that and we get the interior angles or the sum of the interior angles of this polygon. Very good, that makes sense. Let's look at another example. This is a 5-sided polygon known as a pentagon. We are drawing a diagonal from A to D and then from A to C. So you realize that we are forming 3 triangles here. So a pentagon has 3 triangles. So 3 180 degrees triangles here. So if we want to know the sum of interior angles of this pentagon, then we multiply 3 triangles by 180. Yes, that is here. The number of sides is number of sides are 5. 5-sided polygon. So 5 minus 2, that gives us 3 multiplied by 180. That gives us the sum of the interior angles here. It makes sense. So we realize that as the number of sides increases, the number of triangles also increases. So a 6-sided polygon will have how many triangles within it? Will have 4 triangles, because 6 minus 2 gives us 4. Or if we draw it and then we draw diagonals within the polygon, would have 4 triangles. So that's how it goes. So if we have a 12-sided polygon, number of triangles will be what? 10 multiplied by 180. That gives us the sum of interior angles. Very good. Let's look at another formula. Now we know the sum of interior angles. What if we want one angle or just one interior angle of the polygon? Then we divide the sum of the interior angles by the number of sides. That is only if the polygon is a regular polygon, meaning all of the angles are equal, equiangular. So this formula applies to regular polygons only. Finding the exterior angle is 360 degrees over n. So we divide 360 by the number of sides of the polygon. That gives us the exterior angle. Okay, we have another formula here. Exterior angle plus corresponding interior angle gives us 180 degrees. This image best explains what we are talking about here. So this is a five-sided polygon known as pentagon, and X here is an exterior angle, and here is an interior angle. You see that these two angles form on a straight line. So we are calling X here an exterior angle, which is corresponding to N. So both angles are forming on a straight line. So angles on a straight line add up to 180 degrees. That is why we have here exterior angle plus corresponding interior angle equals 180 degrees. Now let's try and see if we can work out some examples. So our first example, a polygon has 10 sides. Find the sum of its interior angle. How are you going to go about this question? You can pause the video and then go through the formulas we generated for solving polygon questions, and then see which of the formulas you can use to solve this question. Okay, so the solution. From the question, the number of sides of the polygon, we are representing that with n, and that is equal to 10. So the polygon has 10 sides, so n equals 10. We are finding the sum of interior angles, so we use the sum of interior angles formula, which is n equals, which is sum of interior angles equals n minus 2 multiplied by 180 degrees. So sum of interior angles, n equals 10, so we replace the variable n with 10. So 10 minus 2 multiplied by 180 degrees. Thus, sum of interior angles equals 8 multiplied by 180 degrees. And that gives us 8 multiplied by 180 degrees gives us 1440 degrees. Let's try another question. If the sum of the interior angles of a regular polygon is 540 degrees, find the number of sides. See, this time around we are finding the number of sides of the polygon. The first example, we found the sum of interior angles. This time around we have the sum and we are finding the number of sides. So solution, we don't know the number of sides, so n equals, we don't know, but we know the sum of interior angles, which is n minus 2 multiplied by 180 degrees. So sum of interior angles, which is the 540 we are seeing here, we equate n minus 2 multiplied by 180 degrees to the 540. So we have 540 equals n minus 2 multiplied by 180 degrees. Oh, so we move our 180 here. That gives us 540 divided by 180 equals n minus 2. Yes, we are making n the subject. We want n to stand alone. So we try and move all of these stuffs here. The first we move is the 180 degrees. So we have 540 over 180 equals n minus 2. So we simplify 540, and then we bring our 2 here to add. Yes, simplifying this, we have 3 equals n minus 2. So negative 2 here crosses the equal sign, comes here, and then turns into positive. So we have n equals 3 plus 2. That gives us 5. So the number of sides of this regular polygon, where the sum of interior angles is giving us 540, is 5. And we know what polygon it is. Yes, a pentagon. Let's solve another example. A polygon has 8 sides. Find the exterior angle, the interior angle, and then the sum of interior angles. So we are finding exterior angle, interior angle, and then sum of interior angles. The only parameter we have here is the sides, 8 sides. So Number of sides, we write that down. N equals 8. We know that exterior angle equals 360 over n. We know the number of sides, so we replace the n with 8. 360 over 8 gives us what? 45. So we have 45 degrees for the exterior angle. So how do we find the interior angle? We don't know the sum of interior angles. So how do we find the interior angle? Note, we know that exterior angle plus corresponding interior angle gives us 180 degrees. So if we know exterior angle to be 45 degrees, and we know that summing that to one interior angle gives us 180, we can find the interior angle. So we replace our exterior angle with 45 degrees as we found here, plus corresponding interior angle equals 180 degrees. We make corresponding interior angle the subject, and then we have 180 degrees minus 45 degrees, and that gives us what? 135 degrees. So that's for the interior angle. Now we are looking for the sum of interior angles. We have two ways in solving this part of the question. The first part, we know that sum of interior angles is 8 multiplied by 135 degrees. Why are we saying that? Yes, the polygon has 8 sides, and so the angles or the interior angles inside the polygon will also be 8. So, and we know that the interior angle is 135. So we multiply that 135 by the number of angles we see in there, and that gives us 1080 degrees. The sum of the interior angles is 1080 degrees. Or we use the formula for finding the sum of interior angles, which is n minus 2 multiplied by 180. We replace n with 8. We know that a polygon has 8 sides. So 8 minus 2 gives us 6. So 6 multiplied by 180 gives us what? Should give us the same 1080 degrees. Yes. So the sum of interior angles here is 1080 degrees. Very good. Let's look at another example. The exterior angle of a regular polygon is 60 degrees. Find the number of sides of the polygon. Also find the sum of interior angles. So we have the exterior angle. We are asked to find the number of sides and also the sum of interior angles. So we know that exterior angle is 360 over n. Yes. Since we know that we can replace exterior angle here with this 60 degrees we have here, and then make n the subject, and then calculate for n. So we have 60 degrees equals 360 over n. Making n the subject, we have n equals 360 over 60. 360 over 60 gives us what? 6. Yes. So n equals 6. So the number of sides of the polygon is 6. We know that sum of interior angles equals n minus 2 multiplied by 180 degrees. So we know the number of sides, 6 minus 2 multiplied by 180 degrees, and that gives us 4 multiplied by 180 degrees. Also, we know that the polygon has 6 sides. 6 sides, 6-sided polygon has 4 triangles. So 4 triangles. So the sum of interior angles of a triangle is 180 degrees. We multiply that with the number of triangles we are forming from this polygon, which is 4. So 4 multiplied by 180 degrees gives us 720 degrees for the sum of interior angles of this polygon. Yes, very easy. Our last question if I'm right. The interior angle of a regular polygon is 4 times its exterior angle. Find the number of sides of the polygon. Yes, so this is more like a word problem. From the question, the interior angle is 4 times the exterior angle. What this means is, if we get the exterior angle and multiply the exterior angle by 4, or yes, we multiply the exterior angle by 4, we get the interior angle. So the interior angle is 4 times the exterior angle. So we know the formula for finding the interior angle, which is n minus 2 multiplied by 180 degrees over n. And we know the exterior angle as 360 over n. So we can equate these two equations and then fulfill the preamble in the word problem, which says that the interior angle is 4 times its exterior angle. So the interior angle here, we are seeing here, is equal to 4 times the exterior angle. Yes, so this is the equation we are generating for the question. Yes, so we move this n here. Moving this n here cancels this n, and so we have a straight equation. N minus 2 multiplied by 180 degrees equals 4 multiplied by 360 degrees. And so we move this 180 degrees here. We want to make n stand alone because we are finding the number of sides. So we are making n the subject. So 4 multiplied by 360 over 180. We cancel this 180 with this 360, and then we are getting 2. So n minus 2 equals 4 multiplied by 2. 4 multiplied by 2 we know is 8. And so n equals, this negative 2 here crosses the equal to sign and it changes to positive 2. And so n equals 8 plus 2, and that gives us 10. So the polygon has 10 sides. Yes, it's a regular polygon. It has 10 sides. Yes, so let's go through the solutions for these questions, and if any of the solutions wasn't clear, let us know in the comment section, and then we'll see how we'll make it clear. So these are your try exercises. So try the exercises, answer them, and then see how best you did. In our next lesson, we'll come up with the solutions before we consider our next topic. So the first question is, the interior angles of a pentagon are 100 degrees, x degrees, into bracket 3x plus 30, brackets close degrees. We have 2x minus 10 in bracket degrees and 80 degrees. We are finding the value of x. Second question, the exterior angles of a polygon are 28 degrees, 40 degrees, 142 degrees, 120 degrees, and x degrees. Find the value of x. All of these are word problems. You generate equations to find x based on the formulas we wrote for polygon. 4 angles of a hexagon are 130 degrees, 160 degrees, 112 degrees, 80 degrees. If the remaining angles are equal, find the size of each of them. So you are finding the size of the remaining 2 angles. If those 2 angles are equal, yes, so you generate equation and use the formulas to write an equation, and then you find for the remaining 2 angles. Find the value of x in the following figures. So this is the first figure. We have x here and we have another x here. Then we have 3x here. So we can see that some of the angles are exterior, or some of the angles are, yes, exterior, and then some are interior. So the same thing you find for x. Yes, so 80 degrees, 140 degrees, x 3x 120 and then x. You find for x. Yes, and this figure also we find for x. So we have all of the interior angles, x plus 40, x plus 40, x here, x plus 40, and then x plus 60. Yes, so you try these exercises, and in our next lesson we'll solve them, and then you see how well you did. Just a hint for this exercise: just get one of those formulas which is suitable for solving these questions, and then you generate an equation, and then you see how you are going to equate those equations to the formulas, or you put these values in the you equate these values to the formulas, and then you see how best you can solve them or find for x. Same applies to the figures you are seeing here. Okay, so this is where we bring our lesson to an end. In our next lesson, we are going to revise on two sets problems. We are going to solve more questions on two sets problems. So the knowledge we have acquired in solving for sets, we are going to apply that to solve word problems involving sets. That is two sets problem. Okay, thank you very much for watching.